Hello everyone, this is Abhishek KV. Welcome to my YouTube channel. I hope you are all doing good. Yes, last class we completed the properties of determinants and we solved some problems on using the properties of determinants. I told you those problems are very important for your annual examination that will be appear in your part E, that is for 4 mark. Yes, let us move on to the minors and cofactor. In this session, I am going to be lecturing about the minors and cofactors, one of the important subtopic in this chapter, determinants. Then the first question is, what is minor? Okay. See, the definition one says, minor of an element. Here, I am going to define a minor for the element of what? Of the determinant. Okay, minor of an element, say that element is Aij. I means row, J means column. Aij, if it is A11, we need to find the minor for what? First row, first column element of the determinant. See, if I have 2 cross 2, A11, A12, A21, A22. First row, first column element of this determinant. So I and j replace it by what? 1 and 1. If I consider A12, first row, second column, second row, first column, second row, second column. See, minor of an element Aij of the determinant is the determinant. It is also the determinant obtained by deleting the ith row and jth column. That's all. See, is the determinant obtained by deleting its ith row and jth column in which the element Aij lies. Minor of an element Aij. Aij lies. Minor of an element Aij is denoted by M, capital letter of M suffix ij. Is it clear? Now I move on to the example. See, minor of an element 6 in the determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. See, minor of an element Aij is obtained. It is also the determinant. It is also the determinant obtained by deleting its ith row, jth column. That's all. See. If the examiner asks minor of an element 6 in this determinant, in which place 6 lies? See, A11, A12, A13, you all know that. A21, A22, A23. See, A23, 6 lies in what? A23. That is second row, third element is 6. Examiner asks minor of an element. The definition says it is obtained by deleting its ith row, jth column. For the element Aij, for the element A23, we need to delete second row, third column. We are remaining with what? See, this implies answer for 1 implies it reduces to, see, this is 3 cross 3. By deleting second row, third column. Why? The definition says deleting the ith row, jth column. What is I here? I is 2. What is j here? 3. Second row, third column. It reduces to what? 1, 2, 7, 8. We already know that. How to determine the determinant of 2 cross 2? 2 by 2. Determinant of 1 by 1, determinant of 2 by 2. And determinant of 3 by 3 we already discussed in previous classes, right? See, determinant of 2 by 2 is obtained by taking the product of diagonal element minus the product of anti-diagonal element. And this determinant, see, minor of this determinant is denoted by what? Mij. What is I here? I is 2, j is 3. This is what? Therefore, M2, 3 is equal to determinant of deleting the row and column. That is second row, third column. We are remaining with 1 to 7, 8. We already know product of diagonal element ones are 8 minus 7 twos are 14. This is equal to minus 6. That's all. I hope you are getting. Just by deleting the corresponding row and corresponding column of an element, the given element. Okay. Here the general definition says deleting its ith row and jth column of the element a, I, j. Here 6 is the element of a, 2, 3. So we need to deleting this second row, third column. Second row, we are going to find the minor for the each element. Here the examiner has only the element 6. Is it clear? See, if I will consider minor of all the elements, find the minor of all the elements in this determinant. Minor of all the elements in this determinant. See, this is A11, A12, A21, A2. We already learned this, right? Then minor of an element 1 is denoted by what? It is denoted by Mij for Aij. For A11, minor of an element 1 is denoted by M11. Is it clear? Then see, what is the procedure? Deleting the corresponding row and column. See, A11 element is 1. We need to delete first row, first column, first row, first row, first column. Remaining with what? 3. Very simple. Okay? Is it clear? Then consider 1 minus 2, 4, 3. Right? Deleting row and column. Then what is the minor of an element? Minus 2. Minor of an element minus 2. Just deleting the corresponding column, corresponding row. We are remaining with 4. This is the minor of an element 2 minus 2. That is first row, second element. A12 element is minus 2. The minor of an element is denoted by M12. By deleting, it is obtained by deleting the corresponding row and column. Is it clear? Then M13. For A13, minor is M13. Again, by deleting what? By deleting, consider the new same determinant. By deleting this column and this row, remaining with what? See, this column, this column, this row. See, fourth element, corresponding row and corresponding column. We are remaining with what? Minus 2. Minus 2. Then M14, that is minor of an element A14 is denoted by capital letter of M14. This is equal to what? See, deleting the row, deleting the column, we are remaining with 1. Therefore, minor of an element 1 is M11, that is 3. Minor of an element minus 2 is M12, that is 4. Minor of an element 4 is M13, that is minus 2. Minor of an element 3 is M14, that is 1. I hope you are all getting this. Just by deleting the corresponding row and column. This is for 2 cross and this is for 3 cross 3. If the examiner has minor of all the elements in this determinant, then you need to find M11 by deleting first row, first column. 5, 6, 8, 9. Is it clear? This is how you are going to find the minor. Okay? I hope you are all getting this. Now I move on to the next one, cofactor. Cofactor is nothing but just multiplying minus 1 to the power of n plus 3. We already did it, right? See, if examiner give determinant of 1, 2, 3, 4, we already know what is that. How can we evaluate this? See, take expanding along R1, R2, C1, C2. There are 4 possibility for 2 by 2, 6 possibility for 3 by 3. R1, R2, R3, C1, C2, C3. If I am going to expand along R1, expand along R1, then plus 1 into, because this is A11 element, we need to consider minus 1 to the power of suffix, sum of the suffix. 1 plus 1, 2. I already told you. It is correspondingly plus minus, minus plus, plus minus minus, y minus A21. 2 plus 1 minus 1 to the odd. If it is odd, minus multiply. See, 1 into plus 1, deleting this column, deleting this row, remaining with 4, minus 2. Why minus? It is A12 element. Again minus 1 to the power of 1 plus 2, minus 1. Minus 1 to the power of 3, odd. Again minus 1. Simply take I plus j is even plus 1. I plus j is odd, minus 1. Minus 2, deleting this row, this column, remaining with 3. So simply we have a int by taking the product of diagonal element minus the product of anti-diagonal element. Product of diagonal element 4 into 1 minus the product of anti-diagonal element 2 into 3. This is equal to what? 4 minus 6. This is equal to minus 2. This is the first part. We discussed in the introduction. We discussed in the introduction class of determinant. And in the previous class we discussed about same expansion, same evaluation by using the properties. In this class I am going to discuss about the minor and cofactor. If the examiner asks minor of the element 1, see, just by deleting this corresponding column, corresponding row, minor of 1 is M11 because A11. This is equal to 4. That's all. Minor. If they ask to evaluate, then you should like this. You should do like this. Is it clear? Then I move on to cofactor. I already told you. Just multiplying minus 1 to the power of I plus j with minor. That's all. See, cofactor of an element aij is denoted by capital letter of aij. Minor of an element aij is denoted by capital letter of m suffix ij. And cofactor of an element aij is denoted by capital letter of aij, capital letter of suffix aij, and it is defined as minus 1 to the power of I plus j into mij. What is mij? Minor. See, if the examiner asks cofactor instead of minor, cofactor of element 6 in this determinant. See, cofactor is denoted by aij. This is equal to, since they given the element as 6, what is the element? A11, A12, A22, A11, A12, A13, A21, A22, A23. For A23, it is capital letter of A23, that is cofactor. Instead of ij, we will write A23 minus 1 to the power of I plus j. I plus j. What is I? 2. What is j? 3. 2 plus 3 into M23. We already find out that. See, deleting this column, deleting this row, this is equal to minus 1 to the power of 5. What is M12? It is minor. Just by deleting the corresponding row and column, we are remaining with 1, 2, 7, 8. This is equal to minus 1 to the power of 5 is minus 1 since it is odd. 8 minus, this is minus 6. 8 minus 14. This is equal to what? Plus 6. This is the difference between minor and cofactor. For minor, you just deleting its corresponding row and corresponding column and obtain the determinant. If it is 3 by 3, then it is reduces to 2 by 2. You know the process. But to find the cofactor, you need to multiply minus 1 to the power of I plus j. What you all already did in the evaluation part. There you need to evaluate overall determinant. Here you need to determine for element. There you need to define for overall 2 by 2 determinant. This is for only element, what they mention. If they ask to find the minor for all the elements, then you need to do M11, M12, M21, M22 for 2 by 2. If they ask to find cofactor, just multiply by minus 1 to the power of 5 plus j into M11. That is minus 1 to the power of 1 plus 1. It is plus 1. You already know that. See, this is all. If minus and cofactor, we already find minus for this. See, minor of this determinant, we already decided M11 is equal to, deleting this column, deleting this row, it is 3. A11 represent what? Cofactor. This is multiplied by minus 1 to the power of I plus j is 1 plus 1, 2 into M11. You already find that 1 into minus 1 square is plus 1 into 3, 1 into 3. This is equal That's all. Then we need to find what? A11. This is equal to minus 1 to the power of n plus 1. I already told you, instead of writing this all times, just you need to verify whether the suffix is odd or even. A11 or even multiplied by plus 1. A12 odd multiplied by minus 1. See, A11 is equal to it is plus 1. A12 is equal to minus 1, suffix odd. A21 again minus 1, suffix odd. A22 even plus 1. Into what? M11, M12, M13, M1. From this we come to know that to find cofactor we need to find the minor first. It is clear? Then M1 into M11. 1 into anything, that thing was the M11. M11 means minor of the element first row, first column. This one. Deleting this, it is plus 3. Deleting this. M12, second column, first row. Then it is 4. Not only 4, it is multiplied by what? Minus 1. Minus 1 into 4, minus 4. Then A21, second row, first column. Second row, first column, minus 2. It is multiplied by what? Minus 1. Minus 1 minus plus. Then deleting this second row, second column. Second row, second column, it is plus 1. Plus into plus 1, plus 1. Is it clear? I hope you are writing. This is the difference between minor and cofactor. Very basic tool to learn the upcoming subtopic, that is adjoint, invertible and system of linear equations. Please note down. Yes. After discussing about the minor and cofactor, the next important tool is adjoint of a matrix. What is the definition for adjoint of a matrix? See, adjoint of a square matrix. To define adjoint matrix, we should need what? Square matrix. Say A is equal to Aij is defined as the transpose of the matrix. See, this is small letter a of suffix ij. This is transpose of the matrix small a changes to what? Capital A. That is, this a should be different. What is a? This capital Aij, where Aij is the cofactor of the element small letter Aij. We are all know what is cofactor. What is cofactor? It is minus 1 to the power of I plus j into mij. What is mij? It is minor. That's why I told you. To define adjoint, we need cofactor. To define cofactor, we need minor. So, I started this session with the definition of minor. We already learned that, right? It is nothing but adjoint of a matrix is nothing but transpose of the cofactor. That's all. For example, find the adjoint A. For this matrix A is equal to 2, 3, 1, 4. 2, 3, 1, 4. See, adjoint A is denoted by this letter. And if the examiner asks, find the cofactor of that element or something, the element 3. This is A12 element. Just by deleting this row and column and multiplying by what? Minus 1 to the power of 1 plus 2, because it is the element A12. If the examiner asks adjoint of matrices, see, to find adjoint we need to find the cofactor for all the elements in the given matrix. That is, we need to find the minor for all the elements in the determinant. So, find the adjoint A for the matrix A is equal to 2, 3, 1, 4. First we should find what? Cofactor. How do we find the cofactor? It is denoted by what? For A 2 by 2 matrices, cofactor is given by A11, A12, A21, A22. For A, small letter A11, it is capital letter A11. Capital letter A11 represent what? Cofactor. See, minus 1 to the power of 1 plus 1 into M11. This is equal to minus 1 to the power of 2. M11 means deleting the corresponding column and corresponding row and corresponding column. It is given by 4. Minus 1 to the power of 1 square plus 1. This is equal to what? Plus 4. Similarly, I I already told you, instead of taking this, just analyze whether it's sum of the suffix is even or odd. To find cofactor, a12 odd, it is minus 1 into, and m12, this is equal to minus 1 into m12 means first row, second column, remaining with first row, second column, remaining with 1. Is it clear? Remaining with 1. 1 into minus 1 is minus 1. A21. Then again it is odd multiplied by minus 1 into M21. What is M21? It is minor. Minus 1 into M21. Deleting the second, this represents what? Second row. Second row and first column. Remaining with what? 3. Minus 1 into 3 minus 3. This is equal to A22. A22, that is second row, second column, remaining with what? Plus 2 into what? Minus 1 to the power of 2 plus 2, it is plus 1. 1 into 2 what? This is M22, this is 1 into 2, this is equal to 2. Then you need to write the adjoint A. To find adjoint, we need to find the cofactor. First we need to find what? Cofactor of matrix A is equal to, what is the cofactor of A11? It is plus 1. A11 is plus 4. A12 is minus 1. Capital letter A3 is minus 3. A22 is 2. This is what cofactor. We need to find the cofactor for each element by multiplying by minus 1 to the power of 5 plus j with the minor. This is the cofactor for all the elements. To find what? Adjoint. What is adjoint? Adjoint of A is equal to, what is adjoint A? By, it is the transpose of the cofactor. What is transpose? By interchanging row to column, column to row. That's all. See, 4 minus 1 it is in first row. Transpose of this first column. Minus 3 2 it is in second row. Transpose of it changes to second column. So this is the adjoint A. That's all. Is it clear? By taking the transpose of the cofactor. To find cofactor, we already learned that. This is the cofactor. By interchanging row to column, column to row, that is adjoint. Is it clear? Yes. This is for 2 by 2. Find the adjoint for this matrix A. See, for this we need to find what? A11, A12, A13, A21, A22, A23, A31, A32, A32. Right? See, this is what? To find adjoint, first we need to find what? Cofactor. Cofactor of first element is capital letter A11 and you need to multiply what? Minus 1 to the power of I plus j. I plus j is what? Suffix of the matrix. See? Suffix of an element. 1 1. I already told you. It is correspondingly plus minus plus minus plus minus plus minus plus. Why? If the suffix is even, then multiplied by plus 1. That is plus. If suffix is odd, multiplied by minus 1. That is the hint, right? So plus minus plus minus plus minus plus minus plus. Now it is enough to find the minor. You already multiplied with minus 1 to the power of I plus j. It is enough to find what? Minor. How do we find minor? By deleting the corresponding row and column. For A11, you need to delete the first row, first column. Remaining with what? 3, 5, 0, 1. This is equal to 3 ones are, you already know, determinant for 2 by 2, taking the product of diagonal minus the product of anti-diagonal. Plus into anything, plus only. Sorry, plus into plus, plus. Then 3 ones are 3 minus 0. This is equal to 3. Then for A12, you need to delete the first row, second column, remaining with 2, 5. Deleting the first row, second column, 2, 5 minus 2, 1. This is equal to what? Minus 1 into 2 ones are 2. 2 minus 10. Minus into minus plus 10. 10 plus 2, 12. 12 into minus 1, minus. See, similarly for A21, A13. Similarly for A13, that is first row, third column, remaining with 2, 3 minus 2, 0. This is equal to 2 zeros are 0. Minus into minus plus 6. Then A21. Deleting the second row first column, we are remaining with minus 1, 2, 0, 1. This is equal to minus 1 into minus 1 plus 0. That is minus 1 into minus 1 plus 1. Then A22, sorry, A22, second row, second column. Second row, second column. We are remaining with what? Second row, second column. Minus 1, 2, 0, 1. This is equal to second row, sorry, second row, second column. 1, 2, minus 2, 1. 1, 2, minus 2, 1. This is equal to what? 1 1s are 1. Minus into minus plus 4. This is equal to 5. Then A31, sorry, A23, second row, third column. It is remaining with minus 1, second row, third column, plus 1, minus 1, minus 2, 0. This is equal to minus 1 into 0. Minus into minus plus, again minus 2. Minus 2. This is equal to plus 2. For A31, deleting the third row, first column, minus 1, 2, 3, 5. Minus 1, 2, 3, 5. This is equal to minus 5, minus 6. This is equal to minus 7. A32, it is multiplied by minus because odd. That is A32. This is equal to minus 1 into. See, third row, second column. 1, 2, 2, 5. 1, 2, 2, 5. This is equal to minus 1 into 5 1s are 5 minus 2 2s are 4. This is equal to plus 1 into 4. 5 minus 4, 1. 1 into minus 1, minus 1. A33. This is equal to minus 1 into. This is equal to minus 1 into. See, A33 is plus 1. Sorry. 3 plus 3, 6. So multiplied by plus 1. Deleting the third row, third column. 1 minus 1, 2. 1 minus 1, 2, 3. This is equal to what? 3 1s are 3. 3 minus into minus 2 or minus 1 minus 2 minus into minus plus 2. This is equal to plus 1. These are all what? The cofactor. These are all what? The cofactor. So, you need to find the cofactor of this matrix. We need to write the cofactor. Therefore, cofactor of matrix A is given by see 3 minus 12 6 3 minus 12 6 1 5 2 1 5 2 minus 11 minus 1 5 minus 11 minus 1 5. But we need what? Adjoint of A. It is nothing but what? Transpose of the cofactor. Simply we define the adjoint of a given matrix A is nothing but transpose of the cofactor matrix. This is cofactor matrix. Transpose of this, changing row to column, column to row. That's all. This row becomes this column. This row, second row becomes second column. Third row becomes third column. See, this is the adjoint of a matrix A. It is nothing but transpose of the cofactor. Cofactor is determined by multiplying minus 1 to the power of 5 plus j with the minor. So, minor, cofactor, adjoint. These three are the basic tool to learn the application of the determinants, which we will discuss in the next class. So, this is about the minor, cofactor, adjoint are the basic tool to learn the application of determinant. That is solution to find the matrix method. Solution for the linear equations by matrix method. Minor, cofactor, adjoint are the basic tool. I hope you are all getting this. Please note down.